Okay, I'm Shiferaw from Ethiopia. Thank you, Mr. Chairman. First, I would like to thank the Dalhousie University for the given opportunity. My title of presentation is Characterization of Heat-Tolerant Rhizobacteria from Hot Pepper Rhizosphere in the Antagonistic Activity against to Fusarium wilt in the Melodogran incognita. This is outline of presentation. Background. The background includes the importance of paper, the production, constant, and the management. The paper is mainly vegetable in the spice crop, belonging to the family of Solanaceae. It's used for various purposes worldwide. Particularly, Ethiopian people have a strong attachment to paper due to its pungency. The fresh one is used as vegetables, as it is shown here, and also when it is in the form of spice, it is used for seasoning or flavoring of different local dishes. It also used as source of income and also as additive in industry. Regarding production, paper is the leading spice cultivating in Ethiopia that share total cultivating area 61.2 with other spice. And also in terms of production, it's around, it's share, it's 3%. But for 2 to 3 past years, it is production, like green pepper is reduced by 14.5, while the red one reduced by 4%. This is due to the emerging of paper wilt Fusarium in the Melodogania incognita disease complex. The recent report, including our previous study, indicates that around 55 to 90% the paper farm infested with Melodogania incognita, and 70 to 93% infected with paper wilt Fusarium. This picture is taken during from the field during sample collection. So, as to improve the production of paper in a sustainable way, rhizobacteria recognized as a best alternative for management of soil-borne pathogens, particularly in tropics where the agricultural system is extremely complex, which is the case for initiation of this study. Thus, during this study, rhizobacteria associated with hot pepper evaluated for the production of plant growth promoting substance and antagonistic activity to paper wilt pathogens. Outcome of the study, out of 147 bacteria isolates, 35 isolates were determined as potent phosphate solubilizing in the indolic acetic acid producers as plant growth promoting substances, while 20 isolates effectively hydrolysis tightly, and 27 isolates highly produce hydrolysis cyanide as antagonistic characters. When I come to this antagonistic assay, again out of 35 isolates, 22 isolates effectively inhibited the mycelial growth of Fusarium, which is ranged for the strain 1, 39 to 57, for strain 2, 49 to 79, for strain 3, 26 to 35, using a dual culture assay. Furthermore, the isolate is evaluated to the Melodogania incognita, so the cell-free supernatants, the secondary metabolite of the bacteria, inhibited the hatching of Melodogania incognita that ranged from 51 to 96%, and also caused the mortality of the J2 that ranged from 45 to 98. Regarding the greenhouse effect, out of these 35 isolates, two best strains further evaluated under greenhouse condition, isolate number 7 for Bacillus cereus and isolate 12 Bacillus ceaminensis. So the two isolates significantly reduce the disease severity of Fusarium and the Mendogania incognita that rated from 4 to 28% in presence of bioagent, but in case of control, only in the presence of pathogen, the rate is increased from 40 to 56. So the isolates are highly performing. Regarding on the identity of the isolate, this using the 16S ribosomal RNA gene, the certified isolated sequenced and identified to 8 species. That includes Bacillus ceaminensis, the dominant one in the isolate, and the well-known.
Can you summarize? Please?
Okay, sorry. The summary. So currently identified microorganisms produce diverse array of plant growth promoting substance in the antagonistic, and also the isolate used for various applications like microplate field in the formulation as biocontrol. And we wanted to extend our study in the future, like ammonium in the iron solubilized bacteria, because here in Ethiopia, particularly in Jimma, the soil is acidic. So acidic soil is chelated. The phosphate is chelated by ammonium in the iron. So we wanted to extend our study on this one if we get the chemical, because there is no in Ethiopia. Another one is we wanted to mark the gene of microorganism responsible for plant growth as well as act as antagonistic. And also another study wanted to screen secondary metabolism of microorganisms, because microorganisms, they use secondary metabolism to attack the pathogens. And also wanted to check specifically there is interaction between paper in the Paniobacillus. There is so in presence of pathogen, because the gene expressed in both sides, in host as well as in bioagent. They support each other. So we wanted to check those genes. Thank you for attention.